Okay, let's have a look here at this question now. Let's see what's going on. So you've got P and Q are the centers of two circles, and they give the equations here, which cut at T, as in the diagram, where PT and QT are perpendicular. Prove that equation. Interesting. So I can certainly oh, actually, that's the part B. Sorry, I should be doing part A first. Okay, so 4,2 is a point on 4,2 is a point on that circle, and PQ is the diameter of the circle. Find the coordinates of Q. Let's complete the square. It's x minus 5/2 squared plus y squared. So that's x squared minus 5x. Yeah, okay. 25/4. So you've got your circle here, 5/2 and 0, and the radius is 5/2. Oh, that's interesting. So that means the circle just passes through the origin. P is 4,2, so it'll be like here, and PQ is the diameter, so find the coordinates of Q. Well, let's have a look here. So if P is 4,2, then to go from 520 to 4,2, you would have to add 2.5, 3/2, 2. So then reversing that, 520 minus 3/2 minus 2, that's 1. And minus 2. So there you go. That's the Q. We can check it's right, because we can check the radius is still 5/2, the distance from here to here. Or we could do the full distance. It should be twice as big. But anyways, that distance would be square root 9/4, I think. Plus 4. 25/4, 5/2, which is what we need. Yeah, so there you go. I've got the Q. R and S are 2 points of the x-axis such that the area of RPQ equals the area of SPQ equals the area of the circle. Express RS in terms of pi. Okay, let me just write in Q here. 1 minus 2. Let me just remove this here. R and S are 2 points of the x-axis such that the area of R, okay, so the area of R PQ equals the area of SPQ equals the area of the circle. Okay, so I think there's some point here. We can just call it R. And there's going to be another point, you know, further out, I would say, on this side, S. And the areas are equal and also equal to the circle. So what I'll do, I'm going to need to know what is, first let's get the area of the circle. That's equal to pi or squared. So 25 pi over 4. Now, what would be the best way to get the triangle's area? So, so let's say, we'll just focus on the S first. Let's say it's at position X. So we'd have to slide all these points back until X is at the origin. So then we'll say that's P dash would be 4 minus X2. And then Q dash would be 1 minus X minus 2. And then the area is, what's it? A half x1 y2 minus x2 y1, I think, if I remember correctly. So that has to be 25 pi over 4. That's a half x1 times y2. So that's minus 8 plus 2x minus x2, which is 2 times y1. So minus 2 plus 2x. Multiply. Well, let's clean this up a little bit. So that and that will get me 2 if I multiply by 2. So I'll have 25 over 2 pi equals the modulus of 4x minus 10. And I should square. So I get 16x squared minus 80x plus 100 equals 225 squared is 625 over 4 pi. Yeah. That doesn't... I mean, I don't feel like I've done anything wrong, but I'll have to solve this for x. Okay, so I realized here what I should do. There's no point in squaring out the modulus. That was a little bit unnecessary. I can just say 4x minus 10 equals plus or minus 25 over 2 pi. So we're just looking, so that's why there's two answers. And we're just looking for the distance, or s. So it'd be the bigger answer minus the smallest answer. So I just add the 10 here and then divide by 4. So the distance, or s, would be, what's going to happen is, and divide by 4. I've kind of run out of space, but I'll just put it there over 4. So that's the x. So the bigger one minus the smaller one. In both cases, the 10s will cancel. So what you'll be left with is 25 over 2 pi minus 25 over 2 pi. So that's 25 over 4 pi, because 50 over 2, which is 25 over 4. Yeah. So that's the, I think that's the A part done. I think it's okay. Let's have a look at the B part now. So we have two circles and the two equations are given, and T cuts, they both cut T, or T is a common point, and it's perpendicular. So I'm thinking we could look at derivatives. It's one thought that occurred to me. We could look at the common chord. Common chord. Common chord. The equation that we have to prove doesn't have an x in it. So if we get the common chord, we'd have to find the x to make them perpendicular. I'm not sure if this is the right way, but just let's write down the equation of the common chord, which you can get by subtracting the 2 here. So that's going to be 2g1 minus 2g2 x plus 2f1 minus 2f2 y plus c1 minus c2 equals 0. So, I mean, it's close. We'll have to do something about the x and the y for sure. But what? Okay, the only other thing I can think of is if we just state what P and Q is. So we have P is minus G1 minus F1. Q is minus G2 minus F2. So the slope, if we say that's M1 and M2, so the M1 would be y plus F2 over x plus G1, and then M2 would equal y, I wrote 2 there, sorry, that's a 1, y plus F2 over x plus G2, and they should multiply. So to get minus 1. So you have y plus F1 over x plus G1 times y plus F2 over x plus G2 equals minus 1. Let's see what happens. So if I multiply at the top, I'll get y squared plus f1 plus f2y plus f1 f2 should equal minus x squared minus g1 plus g2 x plus g1 g2. So if I take everything, let's see, if I take the x squared to the left, what am I going to end up with? I'm not sure if this will be useful to me. I'm just going to remove it for a second. I don't think it will be useful. I think my best way forward might be with the slopes. So if I take everything to the left, maybe I get x squared plus y squared plus g1 plus g2x plus f1 plus f2y plus G1, G2 plus F1, F2 equals 0. Then now let's see this one here, G1 X. So maybe if I multiply this by 2, so everything gets multiplied by 2. Let's make a bit more space. I don't need this here right now. And if I separate it out a bit, so I get x squared plus x squared, I'll put it in later, plus y squared plus x squared plus y squared plus 2g1x plus 2g2x plus 2f1y plus 2f2y plus 2g1g2 plus 2f1f2 equals 0. Let's try and match things up. So 2g1x and 2f1y, but I don't have a c1. So what I'll do is I'll add a c1 and c2 to both sides. So plus c1 plus c2 equals c1 plus c2. So now I've got x squared, 2g1x, 2f1y, and c1. X squared and plus y squared plus 2g1x plus 2f1y plus c1. That should add up to 0. And then x squared plus y squared plus 2g2x plus 2f2y plus c2 should add up to 0. So then all you're left with is 2g1g2 plus 2f1f2 equals c1 plus c2. Huzzah! I've proven that what they've asked me to prove. Okay, good. Good. And they've given us particular S1 and S2 now. And they say if the radius of S2 is length 3, find all the values of G and F. Okay, so all the values of G and F. Interesting. Which in this equation here. Okay, so let's see. The radius is 3, so that'll give us one equation with F and G, and the C is G, and we have this equation here. So let's see what this one can make. I think I can clear this off now. Okay, so using our previous equation here, 2G is the one in front of the x's, so 2G1, G2. So I'll just write down what G1 is so I don't get confused. So G1 is 1 and G2 is G. And then F1 is minus 3 and F2 is F. So using this equation here, that would be 2G plus, so minus 6F equals C1, which is minus 4, plus C2. C1 is minus 4 and C2 is G. Minus 4 plus C2, which is plus G. So that gives us one relationship of G and F. So I can say G minus 6F equals minus 4. Also, we know the radius is 3, so the radius is the square root of f squared plus g squared minus c, which is minus g. And if I square that, I can get f squared plus g squared minus g supposed to equal 3 squared, which is 9. So I've got two equations for f and g, so it should be solvable now. Oh, yeah, okay, so maybe it would be easiest to replace the f. Now if I multiply this by minus 6, so I get minus, oh no, that's f squared, isn't it? Okay. So maybe I'll just replace the g. So I get f squared, and then g is 6f minus 4. So f squared plus g squared, which is 36f squared, minus 48 f plus 16. So that's f squared plus g squared minus g minus 6f plus 4, and then bring the 9 over, minus 9 equals 0. I'm not liking the 37 here. 37f squared minus 54f plus 7 equals 0. Doesn't quite look right, does it? Let's see. No, I think I must have done something wrong with the algebra there, because the quadratic didn't quite work out so nicely. I kind of think that it would have worked out nicely. So let's just go back in time and just check that we formed those equations correctly. Maybe I wrote my formula down wrong for the radius. I thought it was f squared plus g squared minus c. Let's just go back and think about that. Minus g plus f squared plus c squared. No, I'm pretty sure that's right. So 3 should equal the square root of f squared plus g squared minus g. I think that looks okay. So f squared plus g squared minus g is equal to 9. Now let's double check this equation. So g1 is 1 and g2 is g, and f1 is minus 3, and oh, it's not minus 3. That's my mistake here. So I'll just fix that up. I forgot to half it. So it's minus 3 over 2. So let's just double check that now. G1 is 1, G2 is G, F2 is F, and F1 is minus 3 over 2. C1 is minus 4, and C2 is G. That's the problem. So now, okay, 2 G1, G2, so that's 2G, plus 2 F1, F2, so that's minus 3F. That's equal C1 plus C2. That's equal to G minus 4. So now I get G equals 3F minus 4. Okay, now if I put that into this equation, I get F squared plus G squared, which is 9F squared, minus 24F plus 16 minus G, so minus 3F plus 4 minus 9 equals 0. It looks a bit better. 10F squared minus 27F, then 16 plus 4 is 20, 20 minus 9 is 11. Let's see about this one now. That at least has factors. 5F minus 11 and 2F minus 1. So F equals 11 over 5, and g would be 3 times 11 over 5 minus 4. So that would make g equal to 13 over 5, or f equals 1 over 2, and g would be 3 times 1 over 2 minus 4, which is minus 5 over 2. Okay. I think that looks okay. I'm happy that I got actual nice solutions here. Previously, I felt I made a mistake because I got third answers here, which just did not seem like what should have happened. So the fact that this quadratic ended up being factorizable is encouraging. Makes me feel like I did it right, or I got very lucky if the mistake, or unlucky I suppose, if the mistake led to this. I might make a video tomorrow where I graph these circles just to see how it looks. I think I will do that. Okay, this is a long question. This is a pretty tough circle question. Let's leave it there.